There it says the third term of an arithmetic sequence. Now once I see it's an arithmetic sequence, I know I'm using that Tn is equal to a plus n minus 1d. Now they said the third term is 71. Change that English into maths. Third term is 71. There you go. And the seventh term is 55. Find the first term and the common difference. So now just use these numbers, horse them into this. So here we can see that n has been replaced by your 3. So t of 3 is equal to a plus your 3 went in for your n, 3 minus 1d. T of 3 is equal to a plus 2d. And then what can you fill in for your third term? We knew the third term was 71. So 71 is equal to a plus 2d. Starting to look like the old reliable simultaneous equation. Work with your t of 7 now. So your 7 just went in for your n. So t of 7 is equal to a plus n's been replaced, 7 minus 1d. T of 7 is equal to a plus 6t. And what is t of 7? 55. 55 is equal to a plus 6d. Now you've got your simultaneous equations, put both of them together. So to save a wee bit of time, I'll multiply that. Well, I'll multiply this one by minus 1. So minus 71 is equal to minus a minus 2d. That way I get my a's to cancel. There you go. 55 minus 71 minus 16 is equal to 4d. d is equal to minus 16 over 4. Minus 4 is equal to d. Remember, that's your common difference. To get a, horse it into any one of those. So say we fill it in up to that one. 55 is equal to a plus 6 times minus 4. 55 is equal to a minus 24. Bring that across. 79 is equal to a. Seems pretty big, but sure, we'll go with it. So your a 79, d's minus 4. 3 as well might have a wee bit of issues with. And a geometric series. Now, once you see geometric series, that was the second one that you're looking at. So your Sn is equal to a 1 minus Rn over 1 minus r. So you just get the formulas. Start with that. The first term is 12. So S of 1 is equal to 12. Let's see, what can we do with that? Your n's been replaced by your 1, and that's your answer. So a times 1 minus r times 1 over 1 minus r. And that's S of 1 is equal to 12. You know, S of 1 is equal to 12. They actually both go. 1 minus r, 1 minus r. A is equal to 12. Your first term. Worked out nice, but strange. And the other one, and a sum to infinity is 36. So how do you say that? Sum to infinity is 36. That had a special formula. Your sum to infinity formula is equal to sum to infinity a over 1 minus r. So your sum to infinity is 36 a over 1 minus r. We know a is actually 12. So 36 equal to 12 over 1 minus r. Cross multiply. 36 minus 36r is equal to 12. 36 minus 12 is equal to 36r. We still see this, yeah. 24 is equal to 36r. 24 over 36 is equal to r. 12 2/3 is equal to r. R is equal to 2/3. What did they ask you? Find the common ratio. There you go. R is equal to 2/3. You actually knew from this, when it says the sum of the first term is 12, obviously the first term must be 12. A must be 12. You didn't even need to do this. A had to be 12. The sum of the first term had to be 12. Oh, shit. Right. Another few high-tech stuff. So 4 looked alright. Just use your Tn is equal to a by Rn minus 1. We'll look at number 5 here now. Number 5, just matchsticks. The important thing, doesn't matter what the shape is, count them. The Determine the number of matchsticks needed for the nth cube. And that'll tell you if it's geometric or linear. So the first one there is 12 matchsticks. Second one there is 20. The third one there is 28. So from that, I can see that it's a linear sequence because I got the same first difference, or an arithmetic sequence. Or series if we're going to add them all up. So determine the number of matchsticks needed for the nth cube. So for the third cube, the fourth cube, the fifth cube. So I want the number of matchsticks for that or that or that. I'm not adding them up. So it is that linear sequence. So I know I'm using Tn is equal to A plus n minus 1d. A is your first term is 12. D is your common difference, which is 8. So Tn is equal to A plus n minus 1. Your common difference is 8. Should have filled in me 12 there. Tn is equal to 12 plus 8n minus 8. Tn is equal to 8n plus 4. We could always check. So say if I subbed in T of 1, I should get 12. 8 times 1 plus 4 is 12. You're right. If I had second term, I should get 20. 8 times 2, 16 plus 4. Yeah, we're good. So that's for your nth term. And then the second bit of that, the maximum number of cubes in the cuboid, if there are 2006 matchsticks left for construction. So if there are 2006 matchsticks, 2006, so all you've got to do is, what term number is that going to be in? So where is the term number? Equal to 2006, and we're using our previous answer. 8n plus 4 is 2006. 8n is equal to 2002. N is equal to 2002 over 8. N is equal to